at expanding brackets, also known as multiplying out. So a question can use either phrase. It can tell you to expand some brackets or to multiply out some brackets. Okay, so I'm going to start with a very, very simple one. Suppose you were asked to expand 3 bracket x plus 4. Well, first of all, let's take a numerical equivalent to understand why this actually works. Suppose you were asked to work out 3 times 14. Now, there's all sorts of ways that we could do that. But in terms of me explaining why expanding brackets works, let's rewrite this as 3 times, and then let's make a bracket, and rewrite the 14 as 10 plus 4. This would be the same thing as using a grid method to multiply out this. We'd have the 10 here, we'd have the 4 here, we'd have the 3 here, and we would produce a not very tidy grid. 3 times 10 is 30, 3 times 4 is 12, and we would then say the answer is 30 plus 12, which is 42. That is, the 3 has to multiply the 10, and it also has to multiply the 4. The 3 has to multiply the 10, it also has to multiply the 4. Exactly the same principle applies here. The 3 has to multiply the x, the 3 has to multiply the 4. Although I think immediately I want to be a little bit more precise. This 3 is actually a positive 3. This 4 is actually a positive 4. We have a positive multiplied by a positive, making a positive, and then the 3 4s are 12. It's not just the case of copying that plus straight down. It does depend about what sign we have outside the bracket as well. So positive times positive is why we've got a positive there. And we've expanded the bracket. That's that one done. If you have a slightly more complicated one, let's have 2p, let's make it negative 2p, times a bracket containing 3p plus 4q minus 7. Still a single bracket, still works the same way. We need to multiply those. Negative times positive makes negative. 2 3s are 6. P times p is p squared. And so the first term of our expansion, negative 6p squared. Next we have to multiply these. Negative times positive makes negative. Notice how I'm trying to line things up just to keep my thoughts straight. 2 4s are 8, and p times q is pq. And then, lastly, the negative 2p has to multiply this term inside the bracket. Negative times negative makes a positive. 2 7s are 14, p. And so we've expanded the bracket. It gets a bit more complicated if you need to expand double brackets. Let's have a look at x plus 2 times x plus 5. And again, it's perhaps helpful to think of a numerical example just to help us understand what's going on. Let's suppose you had to do 12 times 15. We could write this, you wouldn't, but we could write it as 10 plus 2 for the 12 times 10 plus 5. So we've got the same structure as we do here in the algebra. And again, we could do a grid system. 10 times 2, sorry, try again. 10 plus 2 makes the 12. 10 plus 5 makes the 15. And again, a grid system. And you can see that we're going to get 4 sections to our answer. 10 times 10 is 100. 10 times 2, 5 times 10, and 2 times 5. And we would add all of those up to get our answer. But the key thing to notice is there are 4 chunks, 4 elements. And that's because the 10 had to multiply the 10, but it also had to multiply the 5. And this 2 had to multiply the 10, but also the 5. So these lines, these curves, indicate the different combinations in which you have to multiply things, and we can see it happening in the grid. Which is why when we expand this double bracket, we get x times x making x squared, positive x times positive 5 making positive 5x, positive 2 times positive x making positive 2x, and positive 2 times positive 5 making positive 10. These are like terms. We can gather like terms, and so we have x squared plus 7x plus 10. So we've expanded our double bracket. Let's look at another example of a double bracket, but this time more complicated. Suppose we had 2x plus 3 in one bracket and 4x minus 7 in the other bracket. Exactly the same concept. I would advise you to get into a habit of always writing the curve, doing the algebra, then writing the next curve, doing that piece of algebra. Don't draw all the lines in and then do all the algebra. The point of drawing in the line is it helps you focus on what you're doing at this moment. So 2x times 4x is 8x squared. Positive 2x times negative 7 is negative 14x. Positive 3 times positive 4x is plus 12x. And positive 3 times negative 7 is negative 21. So we've got 8x squared minus 2x minus 21. One last example, and this time we're going to look at expanding a triple bracket. This is maybe halfway through the GCSE course. Let's suppose we have 2x plus 1, x take 2, and x take 5. This is going to take more work. What we do is we pick out 2 brackets, and it's probably just easiest to take the first 2, and we expand those. And the x minus 5, we don't worry about it for the moment, we just leave it sitting on the end. We'll deal with it later. So 2x squared minus 4x plus x minus 2. These terms simplify. If we don't bother simplifying, then when we multiply these 4 terms by these 2 terms, we are going to get 8 terms in the next line of working. That's unwieldy. It's inelegant. So we take an extra line to simplify those 2 like terms, so that now when we multiply these 3 terms by those 2 terms, we will get 6 terms. Much better than the 8 terms we would have got out of here. Now, 2x cubed take 10x squared minus 3x squared plus, be very careful of that plus, negative times negative makes a plus, negative 3x times negative 5x plus 15x. Now the lines get a bit untidy, but we need to multiply this negative 2 by this x, and this negative 2 by that negative 5, so plus 10. Now, because we've done these in a consistent order, we actually get terms coming out in a helpful arrangement, because we can see much more easily which terms combine together. And so it's taken us 5 lines to expand that triple bracket.